Terrific. Hello, everyone. About a year ago, there was a company that came to MIT to ask about this new thing called generative AI, or at least they had only heard about it recently with the release of ChatGPT. And this was a sophisticated company. They built complex devices. They had a big engineering team, an engineering team that actually knew how to develop certain AI tools. They had done machine learning before, but they were puzzled by this new generative AI thing. They had read about it in the news. They had heard very esteemed people saying it was the biggest thing since the internet. But when they tried to solve problems within their company, problems they thought this tool was perfect for, like customer inquiries that had multiple different types of data that were required to answer, they kept getting the wrong result. So they said, we set up these questions, questions that we knew the answer to. We gave them to the LLM, and then it couldn't consistently give us the answers we were expecting. What are we doing wrong? And we weren't really prepared to answer the question. But by the end of the conversation, one of the engineers said, you should title your research, "It's Not as Easy as It Looks." And that's why I'm here today, as part of a research group that's trying to understand how companies, large and small, across the world, are experimenting with generative AI to try to tap into some of the potential that you heard about earlier today in the presentations about all of the really amazing things that these tools can do in principle that are actually quite hard to do in practice. So I want to talk a little bit about the practice. And where I come from academically is I do research on the ways that technology affects work and workers. So I've long been interested in robots and robotic process automation, technologies that even, it's a tale almost as old as time, the last 50 years, the predictions have been that robots or something like robots will displace all sorts of workers doing routine jobs. And this has led to anxiety in the United States and elsewhere that there might be some big displacement. But when research has been conducted in the US, in Canada, in France, the list goes on, it finds that when a company adopts a robot or robots, it actually hires more workers, it becomes more profitable and more productive. So this technology seems like it has a ton of potential when companies adopt it at scale. However, what we also see is that not many companies with the ability to use robots actually use them. That in the US, only 12% of manufacturing firms have any robots at all, despite having a lot of potential use cases. So the puzzle isn't really why are robots stealing jobs, as it's been traditionally, but it's why is it so hard to use robots appropriately to grow a manufacturing company? And one of the questions that we had with the advent of ChatGPT and companies like the one I described coming into our offices and asking about challenges of adoption was, is this really the same story as robots, as the technologies that we had known before, or is this something very different as it had been presented to us, something on the scale of the internet? So this was kind of the beginning question that we embarked on in our research, and I want to share with you some early findings. And I'll give you kind of the framework that we've been looking at. That's a little rudimentary here. But what we realize is that there are certain fundamental characteristics of large language models, and I'll just use ChatGPT as an example, one instance of this type of technology, that's quite different from robots and other, what I would say is automation technologies that we might be familiar with. And the difference is this. So we have two axes that we think about for these technologies. One is robustness. If you give the technology a certain task, how reliably can that technology perform the task over and over again once it's given that task? If you give a robot a task to load and unload a machine, as long as the conditions are the same, the robot can reliably load and unload the machine as long as it has power and as long as the tooling doesn't wear, right? It's a very reliable performer of a certain task. However, it doesn't have much flexibility. If you give it a different task, it actually takes a lot of work to teach the robot, to program the robot to do the new task. And what I think is really interesting about this isn't just the ability of the robot to perform some tasks but not others, but it's the role of the human in this situation. So the human, to get the robot to be flexible, it needs to exercise the flexibility themselves, right? Humans need to be problem solvers to teach the robot the new task. That's the role of the human worker when it comes to robots. Now, if we think about the large language models and the examples that you've heard about today, they're quite different. That you can give these models all different types of tasks. You can ask it to analyze an image. You can ask it to analyze data in a variety of different forms, and it will give you an answer. It will, in some way, perform the task. But will it give you the same answer time and time again? Will it give you the right answer? That's an open question. So really what we're saying is that this technology has flexibility without robustness, and the role of human workers, quite differently than working with robots, is to give it a sense of reliability. Something that you might have heard, referred to as the human in the loop needs to be able to give the technology its reliability. So we thought, okay, so this technology seems to be different. It might be having a very different impact than robots. What might that impact look like? So what we did over time was we started to look at companies. Now we have about 60 companies in our working group. I lead it with two other great scholars at MIT, Kate Kellogg from the Sloan School of Business and Julie Shaw, who, like some colleagues here today, is affiliated with CSAIL. And what we did was we started asking these companies a common set of questions. Where are you using generative AI? Where is it working? Where isn't it? What's the impact on the skills you require as part of your company? And these are companies from around the world, across industries. But one key thing is these aren't the creators of new models. So Google is an anchor member of the group, but it's not the Google, Amazon, OpenAIs that are really driving this conversation. It's large insurance companies, large financial institutions, companies that have the tasks that these models can potentially do. And what we found through many of these conversations is that the current experiments with generative AI fall into three buckets. There are these tasks that what I might think of as near routine. They're not quite automatable with a traditional maybe RPA bot or other software, so they need a little bit of flexibility, but they're pretty close to routine. They have the same shape. And then there are tasks like making more complex decisions with a variety of data. These tasks you've heard a lot about today. And then finally, there are more kind of innovation. Can we do new creative things, like what the professor just before me was discussing? And through these conversations, we've been able to develop kind of a rough plot of how these different use cases fit. So it seems like the technology tools are quite good at doing the near routine tasks, that they can do them in a pretty good way, and companies have begun to scale up these types of use cases. The technologies also seem to be pretty good at helping individuals exercise their creativity. Not necessarily being creative on their own, but as a kind of a way of augmenting new capabilities. However, we haven't seen a lot of companies yet understand how to scale this up within their organization. At the individual level, there might be individual workers who are using things like ChatGPT or other tools to be creative, but not necessarily in a systematic way at the companies we're studying. So let me go through each of these, and what I want to emphasize is that each of these applications, each of these use cases has significant trade-offs. In economics, you might have heard the phrase, there's no such thing as a free lunch. And really what that means is that even if the technology tool seems wonderful and it's performing really well, there's also going to be costs to it, not just monetary, but otherwise within your organization. So what I'll go through with each of these is some of the benefits and really the promise of these applications, but also the trade-offs that I think companies are already beginning to see. Okay, let's start with the near routine tasks. And I'm going to give you two of the first studies. Some of these have been in reference today, but I think it's worth reinforcing them. So two of the first experimental studies of generative AI in the workplace. One on the left was in a lab. The one on the right was actually in a call center for customer service workers. The one on the left was one you might have seen in the news. It was actually published in Science by some graduate students in economics who are in our working group. And they gave a group of just experimental subjects, they gave half access to generative AI, and they gave half just a computer, and they said, prepare a press release, essentially write a short essay capturing certain bullet points. And then they had a group of anonymous reviewers look at the essays and grade them on their quality, essentially which were the best written, which communicated the information. And what I think was really surprising was not only that did the people with generative AI write faster, they were able to compose the essay far faster than the group without the aid of generative AI, but they also wrote higher quality essays. Now, might not be surprising. This is particularly among Americans, we're not the best writers. But what was also surprising was that those individuals with the poorest writing skills, so at the lowest end of the skill distribution, saw the biggest gains in their writing performance. So unlike computers, the internet, which have long been considered skill biased, that people with the most education and the most skills seem to benefit from them, this seemed to be the opposite. This seemed to actually be an aid to people without as much education, okay? And then later, in a real workplace for customer service agents, similar design. Some customer service agents were trained to do their jobs with large language models by their side. Some were trained in a more traditional way. And then the researchers, they compared the performance of these agents. And you can see, and you might have already just taken a look, is that the agents in the blue line who never received training with generative AI, this is their learning curve. Over time, as they got more experience in the job, they went from resolving about 2 customer calls an hour to just under 3, right? So a gradual learning curve. And then the agents that received help from the large language model had a much steeper learning curve and essentially achieved the productivity of a more experienced agent in less than half the time. So again, this kind of blockbuster study, so much excitement about the potential of these generative AI tools to really transform work, to increase the performance of these organizations. Okay, so what might be going on here, and why might this be an incomplete picture? So I want to reflect now on some of the projections that came out after findings like these. So some people began to take these findings of big boosts in productivity for individual tasks like customer service and writing an essay, and they said, we're going to have a productivity revolution in the United States or around the world through the use of generative AI, that we're going to see a big increase in standard of living. There were also some concerns that there might be this big displacement in workers. There were similar concerns, some of you might remember, with the growth of the internet, that this technology was also thought to dramatically improve the productivity of certain tasks, like communication. Instead of faxing, you could write emails. So what happened after that was that although economists expected productivity overall in the broader economy to spike in the late 90s and early 2000s, they found that actually productivity didn't grow any differently at all. It kept on quite a steady pace. So even though the internet really changed so much of how we work and our lives, it's been referred to now as the productivity paradox, that these technologies transform so much of what we do, but they don't really give us the productivity benefits to show for it. So one of the questions is, do these tasks that generative AI is helping us do faster, are they actually going to translate into long-term productivity? And one of the questions that I think is important to ask is, does writing a press release faster or resolving a call faster translate into real value added for an organization? Is it going to allow that organization to reach more customers, to produce more products of a higher quality, et cetera? Things that are actually what we measure when we measure productivity. It's value added per worker hour, not just the speed of individual tasks. And here's just the data behind the productivity paradox that you'll see in 1920 to 1970, before any of the IT revolution. We actually see, and this is true for European data as well, we see higher productivity growth than we see in the kind of the IT revolution era. And you can decompose it a little, and you might see a little bump in the 90s, but this is overall where the productivity paradox gets its basis. One thing we're also seeing as these new technologies are deployed, we had one organization that came to us and was saying, we're not really sure. We're beginning to see an association between the adoption of these new tools and teamwork, the ability for workers to consult one another and work in teams. And if you think back to the first example that I mentioned about a complex customer question that comes into the organization, and the idea was now you can ask an LLM to give you an answer. Previously, without technology assistance, what you might do is you'd go to the cafeteria and you would find your coworkers that might have different expertise, and you'd talk to several of them, you'd hear their input, and then you would assemble that input into an answer that reflected the diverse expertise of your team. The whole idea behind having an LLM do the job was that it would be able to take that expertise as codified in different documents within the company and provide the answer in a much faster time. But what this company was worried about is what happens to the team dynamics? Are we not actually going to know which coworker has what expertise? And what might we lose by not working as closely together with our coworkers? And this wasn't necessarily the concern of the company, but I think one thing that we can all be concerned about is that how does this affect the quality of jobs that people are doing on these teams? You go from a collaborative environment where you might actually get energy and get new knowledge from your coworkers that actually might give you pleasure at work, to trying to resolve this on your own and trying to vet the LLM and see if the answer it gave you was correct. Okay, so the second piece of this puzzle, and I think for a lot of organizations is an exciting opportunity, is to help you make better decisions. And one study that my colleague Kate Kellogg was a part of that I think gives us some really important insight into this question was done with consultants from a group called, it's Boston Consulting Group. And what they did, similar experimental design, half the consultants access to LLMs, half the consultants not. And then it gave the consultants a series of tasks. The first task was to come up with a new pitch for the product launch of a shoe. They thought this is kind of a creative task. It's a task that might require some writing. So the consultants that got access to the LLM did quite well. And similar results, it was the consultants with the LLM performed better on the task, and also the lowest skilled consultants saw the biggest performance increase. Okay, consistent. Then they gave the consultants a second task. And that task was it was more similar to the complex problem-solving task, where they had to take data from a spreadsheet, data from interviews, and then synthesize it to come up with a recommendation to a company on what it should do in a certain market. Essentially, should the company invest in market A or market B? And if you actually analyze the interview data and the spreadsheet data, it was pretty clear that the answer was B. But if you gave individuals access to the LLM was confused by the problem, and it kept recommending A. Now, the LLM might have been confused, and it's anthropomorphizing the LLM to call it confused, but nonetheless, it might have given you A and not been had the evidence to provide the answer, but it was so persuasive that these highly educated consultants kept answering A if they had access to the LLM. So the consultants with access to this technology actually performed worse on the task where the LLM wasn't prepared to give the right answer. So what can we learn from this? What the authors of this study suggest is that there's a jagged frontier, they call it. On the inside of the frontier are the tasks where the LLM has a comparative advantage over individual workers, and it's useful to actually engage with the LLM to do your work and perform a task. Then there are tasks like this multimodal data problem that are outside the frontier, and the LLM doesn't have a comparative advantage, but it's still going to give you an answer, and quite a persuasive one. So what they concluded, I think quite rightly, is that one of the big challenges, and it's not really one easy to resolve, is figuring out which tasks within an organization or within your own life are within the frontier or outside the frontier. And to add maybe insult to injury, one of the other difficulties is that because the underlying models are changing, one task that might be inside the frontier today could be outside the frontier tomorrow. So this is a moving target. Okay. Finally, and then I'll wrap up. So this is, I think, one of the areas that gets me excited, but also a bit daunted by the growth of this technology, is that perhaps this technology could enable individuals to discover new medical treatments, come up with new ways to address climate change. A lot of colleagues who were here discussing this, really some inspiring potential applications of this technology. But then again, the humanities offer some concern that will the potential creativity that this could unleash, could this in some ways actually reduce our ability to be creative and be human? So there's really two sides to this coin. And what I want to emphasize is that we don't really have a good way of studying this yet. So there was a recent study that, this was covered in the Wall Street Journal. It had a kind of a provocative headline, essentially business students versus ChatGPT, who are the better inventors? And the conclusion of the newspaper article was that ChatGPT was actually more creative than humans. And I read this and I was immediately skeptical. I said, really? This is really what the paper concluded? So I went and I found the paper, and I want to show you what they concluded. So first, all of you who are familiar with reading these types of tables, this is not a definitive conclusion. There is no statistically significant difference between between this group on the right, a prompted GPT-4, and the humans, right? It's a little bit higher, but it's not that significantly different. And what the design of this study was, just to give you a sense, was they asked the group to come up with inventions, and then they gave a group of potential consumers, they asked them, would you buy this invention from the algorithm or from the students? But then it gets even kind of funnier when you look at the inventions that the algorithm came up with. So here are the top-rated inventions, and you might read through some of them and be like, this isn't an invention at all. This is something that already exists. And it already exists. Partly, if ChatGPT came up with it because it already exists. It's probably because the information that fed the model was already, so like a collapsible laundry basket, collegiate cookware, not quite the most creative inventions that you could imagine. Okay, so the creativity question I think is still an open one. And finally, what I will leave you with is that we have, even though there are still a lot of open questions, we're not even 2 years in to this venture of studying how organizations are using these tools, I think there are some lessons we can draw on from other fields of study that can be useful in thinking about the trade-offs that we face and the kind of the hidden consequences of some of these use cases. So I'll just give you kind of an example from aviation in cockpit automation. So when I teach a little bit of human factors and automated systems, and one of the really remarkable findings from this field is that with each new wave of cockpit automation, there were increasing safety incidents before they went down. So safety has gotten better over time, but there are these bumps, and the bumps were associated with introductions of new automation technology. And one thing that they found, so why does safety get worse before it gets better with introductions of new technology? Part of it is how the human, the pilot, is interacting with the autopilot technology. Is that the pilot could become too relaxed, not as vigilant about the surroundings when the technology becomes so good. They lose their situational awareness. The pilot also, and this goes for security agents, people in air traffic control, can have too many inputs, too much data, such that the cognitive load is too high and they make worse decisions, right? These are backlash effects of introducing new technology without thinking about the skills and preparation of the humans who are using them. And I think hopefully this will transition into the topic for the panel, which is all focused on kind of how we can use these tools most effectively for the benefits of humanity. Thank you very much.